Good day, class. Welcome to our next lecture topic regarding clinical laboratory supplies. At the end of this lecture topic, you are expected to list the commonly used laboratory supplies and describe their specific functions. You need to also differentiate between the terms to contain and to deliver. This refers to the different pipettes that I will be discussing later. Also explaining the difference between volumetric pipettes and graduated pipettes. Have a list of a procedure for the preparation of reagents. Describe the proper procedures in order to use your pipettes. Describe the proper operation, maintenance of centrifuge in the clinical laboratory. List examples of types of glass and plasticwares used in the clinical laboratory supplies and describe their useful qualities. And lastly, list and describe the 4 grades of chemicals and explain how they differ in their degree of purity. So what are pipettes and why are they very useful in the clinical chemistry laboratory? Pipettes class are either glass or plastic utensils used to transfer liquids. They may be reusable or disposable. Although pipettes may transfer any volume, they are usually used for volumes of 20 milliliters or less because larger volumes are usually transferred or dispensed using the automated pipetting devices or jar-style pipetting apparatus. This slide class, you can see that these are different types of pipettes that we use in the laboratory. So let's discuss this one by one because they have different functions, they have different calibration marks or designs, and there are also different types of these pipettes. So let's get to know them one by one. Before that class, allow me to introduce to you the different organizational groups that are responsible for the acceptance of pipettes. We don't just go around using certain pipettes that are not true or not calibrated for that certain measurement. So, of course, no, they have created several groups to verify and to standardize our pipettes in the laboratory. The first one is the National Institutes of Standards and Technology, and the other one is the American Society for Testing and Materials. The National Institute of Standards and Technology, which is also known as the National Bureau of Standards, they have established tolerances for different volumetric glassware used in the clinical chemistry laboratory. They also provide a calibration service for the different manufacturers of volumetric labware that directly links the glassware standards to national and international standards. While the American Society for Testing and Materials, this is actually a membership organization that writes voluntary consensus standards. Each pipette is calibrated in accordance with the American Society for Testing and Materials E542 and must meet the accuracy requirements of ASTM E969. So this is what a pipette looks like. So here are the parts. This area here is what we call the suction tube. That is where we attach the rubber bulb. Later, I will show you what it looks like. This area here is the one that you can see that it's enlarged. And let's read each of the writings and labels one by one. And this area here is the delivery tube. So this part here is the portion where you attach or where you place the pipette's delivery tube to the receiving vessel. So the area here is for the suction bulb. So suction tube in this area. So you will see there's a suction bulb later. And this area here is the delivery tube where you place it on the receiving vessel. Let's go back here. So In a pipette class, it must contain the name of the manufacturer. If there's an ISO association mark, the country of origin must also be placed. The trademark or the brand is also there. The nominal volume, so the contents or the measurement or the volume of this pipette that it can hold. So this, it says here, it's 25 ml. The error limit is plus minus 0.03. So this is the error limit for this pipette. It must also contain the reference temperature. So in here, it's 20 degrees Celsius. Your waiting time before dispensing the fluid to the receiving vessel. So that's 5 seconds. Calibration, this one is TD. What does TD mean? TD is to deliver. Oh, here, it says here to deliver. Also, it contains here a Class A, the highest quality grade. And when you see the word or the letter S, it's for swift delivery. So those are the labels or the writings that can be seen in a certain pipette, and that must be seen in your pipette. The photo here, class, shows the different pipette bulbs, and this one is a coal-filled. You call this a coal-filled, while this type of pipette bulb or suction bulb is called the spectroline. And this one is the common pipette bulbs that we can see in the laboratory, that's safety bulb. We have both coal-filled and safety bulbs in the clinical chemistry laboratory. These pipette bulbs or suction bulbs are used to help suction the fluid from another container in order for us to aspirate the fluid and transfer it to another vessel. So these are the things that we need in order for us to transfer fluids. We don't do mouth pipetting anymore, class. Mouth pipetting is so obsolete, so please do not do it in the laboratory. We make use of these different suction bulbs. The pipettes in the laboratory class have different classifications. That is, one for design. The next would be the draining characteristic of the pipettes. And lastly, what type of pipette classification does that belong? Similar to many laboratory utensils, pipettes are designed either to contain or to deliver a particular volume of liquid. The major difference is the amount of liquid needed to wet the interior surface of the ware and the amount of any residual liquid left in the pipette tip. Most manufacturers class stamp either TC or TD near the top of the pipette. That's to alert us, the users, as to the type of pipette is used. So this is under design, either TC or TD. Like other TC designated labware, a to-contain pipette holds or contains a particular volume but does not dispense that exact volume. However, for a TD or to-deliver pipette, this will dispense the volume that is indicated. So even if it says here 20 microliter, we are not particularly sure that the amount of fluid being dispensed is exactly 20 microliter. Compared to that of the to-deliver pipettes, there is a certain calibration here that says 10 ml or 25 ml, and it can really dispense that exact volume that is indicated in your pipette. Let's go back to this diagram here, class. So when using either the pipettes, the tip must be immersed in the intended transfer liquid to a level that will allow the tip to remain in solution after the volume of liquid has entered the pipette. So this is what it looks like. And make sure that you do not touch the vessel wall. So either here, here, or below. Make sure you don't touch those. The pipette is held upright. So it must be straightened upright, not an angle that is slightly on this angle or any angle. Just hold it upright, okay? So using a pipette bulb or any similar device, a slight suction is applied to the opposite end on this area here until the liquid enters the pipette and the meniscus is brought above the desired graduation line. So this area here, can you see that? And then when you already got the desired volume that you want, suction is then stopped. While the meniscus level is held in place, the pipette tip is raised slightly out of the solution. So you remove it out of the solution and wiped with a laboratory tissue of any adhering liquid. And then the liquid is allowed to drain until the bottom of the meniscus touches the desired calibration mark. With the pipette held in a vertical position and the tip against the side of the receiving vessel, the pipette contents are allowed to drain into the receiving vessel, so to another vessel already. Another thing that we should place or put into consideration are the draining characteristics. We have two, that's either blowout or self-draining type of pipettes. A blowout pipette class has a continuously etched ring or two small closed continuous rings located near the top of the pipette. This means that the last drop of liquid should be expelled into the receiving vessel. Without these two continuous rings, then you call that type of pipette as self-draining. And us, the users, we are allowed to dispense the contents of the pipette to drain by gravity. The tip of the pipette should not be in contact with the accumulating fluid in the receiving vessel during drainage. An example of self-draining type of pipettes include Moore pipette, volumetric pipettes, and Vance-like pipettes. Remember, as what I have said a while ago, you should not be touching the tip of the pipette into the receiving vessel during drainage. But that is with the exception of Moore pipettes, because Moore pipettes, when you're using this class, the tip should remain in contact with the side of the vessel for several seconds after the liquid has drained. The pipette, after that, is then removed. So the rest of the other pipettes, you drain them by gravity, except for Moore, you need to place the tip in contact with the side of the vessel during draining. By the way, an example of a blowout pipette is a serological and Oswald-Follen type of pipettes. So here's an example of a blowout pipette. There are two continuous rings on the top of the pipette. This is to prompt us users that the final liquid or the final fluid must be blown out. This photo on the left side class is what we call the Moore pipette, or also known as the graduated pipette. And this is the type of pipette used to measure the volume of the liquid dispensed, although not as accurately as a volumetric pipette. The one on the right is what we call the automated micropipettes. So these are micropipetting devices because they can dispense 0.1 to 2.5 microliters. Oh, that's just microliters. These are the new and advanced pipettes that we have, semi-automated pipettes in the laboratory. Okay, just a brief recap. We're already done with the designs of the pipettes. That's either to contain or to deliver. We also have the different draining characteristics of the different pipettes. That's blowout type of pipettes and also self-draining type of pipettes. And lastly, let's discuss what type of pipettes are they. Okay, first one are measuring or graduated type of pipettes. The first example under measuring or graduated are serologic pipettes. Serologic pipettes are measuring or graduated type of pipettes that are to deliver type of pipettes at the same time, and generally a blowout pipette. This means serologic pipettes are measuring or graduated. Its design is to deliver, and its draining characteristic is a blowout pipette. So now you understand, class? That's under serologic. Do not forget, a serologic pipette, class, has a graduation mark up to the tip. So it has a graduation mark until the tip area. Another example of a measuring or graduated type of pipette is more pipettes. More pipettes, aside from a measuring or graduated, remember they are to deliver type of pipettes. That means they can deliver the indicated volume. At the same time, there are self-draining pipettes. As what I have said a while ago, that while you're draining the fluid to the receiving vessel, you remain the tip in contact with the vessel until all the fluids are drained. Right? So measuring or graduated type of pipette, it's to deliver, that's its design, and it's self-draining, that's its draining characteristics. The difference between serologic pipettes from more pipettes, class, is that more pipettes does not have graduations to the tip. So it doesn't have a graduation or markings, number markings up to the tip. The tip of the pipette, as what I've said, should not be allowed to touch the vessel while the pipette is draining. But you remain the tip touching the vessel until it's fully drained. Now you understand the difference between serologic and more type of pipettes? Okay, let's proceed. Other examples of measuring or graduated type of pipettes include bacteriologic pipette. There's also ball, Calmer, and can pipettes. There are also micropipettes. Micropipettes, class, hold a total volume of less than 1 milliliter. An example of which are Sally Hillige pipette, Lang-Levy pipette, the RBC and WBC Thoma pipettes. So this picture here are the RBC, red blood cells, and WBC or white blood cell Thoma pipettes. There are also Kirk and overflow pipettes. So those are examples of micropipettes under the measuring or graduated type of pipette. Okay, now we're done with the measuring or graduated type of pipettes. Let's move on to the transfer type of pipettes. Transfer type of pipettes, class, under which is a volumetric pipette. A volumetric pipette has a transfer type of pipette. Its design is to deliver, while its draining characteristic is self-draining. So a volumetric pipette is a transfer pipette that is to deliver type of pipette and at the same time has a self-draining characteristic. It only measures one volume, so if it says there 50 ml, then it can only dispense 50 ml. Volumetric type of pipettes transfer non-viscous fluids, so that includes water. So make sure that's non-viscous. It's self-draining. The small amount left in the tip should not be blown out. Remember, it's a self-draining pipette, so you leave it as is. You don't blow out the small amount left in the tip of this transfer pipette. Usually, volumetric type of pipettes have been used to add the diluent to a lyophilized control or to measure standards and control. So this is a volumetric type of pipette. Another type of transfer type of pipette is the Ostwald-Follin pipette. Ostwald-Follin pipettes are transfer types of pipettes that has a to deliver as a design and has a draining characteristic of blowout. This means again, Ostwald-Follin is a transfer type of pipette that is a to deliver pipette, and at the same time it has a blowout draining characteristic. The bulb of this Ostwald-Follin class is closer to the delivery tip, reducing the surface area in contact with the liquid. This Ostwald-Follin type has an etched ring. It has an etched ring. So it has an etched ring here. An Ostwald-Follin type of pipette has an etched ring. And it is used for viscous fluids. The volumetric pipette a while ago is for non-viscous fluid, while the Ostwald-Follin pipette is for viscous fluids. And also, the final drop is blown out compared to that of the volumetric pipette, that the final amount or the small amount left on the tip should not be blown out. Another example for a transfer type of pipette is a Vance-like pipette. Vance-like pipettes class are thick-walled capillary tubing with bulb in the center. So thick-walled capillary tubing with bulb in the center. This is a Vance-like pipette. While a Sally pipette, they can deliver 20 microliter. So it's a to contain type of pipette and at the same time a transfer pipette. Sally pipette. Another example of a transfer pipette are the Pasteur pipettes. They do not have any calibration marks and are used to transfer solutions or biologic fluids without consideration of a specific volume. So again, Pasteur pipettes, these are Pasteur pipettes. They transfer fluid without consideration of a specific volume. And this one on the right is what we call the automatic or semi-automatic micro or macro pipettes. They are to contain type of pipette as a design. They're also transfer type of pipettes, and they're the most routinely used pipette in the clinical chemistry laboratory setting right now. They also measure small amounts of liquid. Usually, they can dispense up to 0.1 microliter up to 1,000 microliters. The automatic pipette is the most routinely used pipette in today's clinical chemistry laboratory. The term automatic, as used here, implies that a mechanism that draws up and dispenses the liquid is an integral part of the pipette. It may be fully automated or self-operating, as what we have seen inside the automation or machines used to aspirate blood sample. So inside the machines or equipments in the laboratory, there are automatic pipettes there. They dispense the sample on their own, so that's fully automated or self-operating. The one that is used in the laboratory, we use the semi-automatic or semi-automated pipettes. The automatic and semi-automatic pipettes have many advantages, including safety, stability, ease of use, increased precision, the ability to save time, and less cleaning required as a result of the contaminated portions of the pipette. A pipette class associated with only one volume is termed fixed volume type of pipettes. But most usually, the common or available models of the pipettes are termed variable because we can select here. You can see that there's a predetermined volume that could aspirate, or that we could aspirate the sample using these volumes only from 10 to 100 microliters. So we just set the measurements here so that the pipettes or the pipette tips could dispense only the required volume that you want. So that's what you call variable models of semi-automated pipettes. Remember, a pipette with a pipetting capability of less than 1 ml is considered a micro pipette, while the pipette that dispenses greater than 1 ml or 1000 microliter is called an automatic or semi-automated macro pipettes. In addition to classification by volume delivery amounts, automatic pipettes or semi-automated pipettes can also be categorized according to their mechanism. Either it's air displacement, positive displacement, and dispenser or diluter type of pipettes. An air displacement pipette class relies on a piston for creating suction to draw the sample into a disposable tip that must be changed after each use. So it has a disposable tip. The piston does not come in contact with the liquid, air displacement type of pipette. While a positive displacement pipette, it operates by moving the piston in the pipette tip or barrel, much like a hypodermic syringe. It does not require a different tip for each use. But carryover concerns, there's an increasing carryover concerns for positive displacement pipette. Rinsing and blotting between samples may be required when using positive displacement type of pipettes. While for dispensers and diluters, or dispenser or diluter type of pipettes, these are automatic pipettes that obtain the liquid from a common reservoir and dispense it repeatedly. So the dispensing pipettes may be bottle top, motorized, handheld, or attached to a diluter. The diluter often combines sampling and dispensing functions. Okay, in this diagram here, you can see the difference between an air displacement pipette from a positive displacement pipette. Remember, as what I've said a while ago, that an air displacement pipette, it relies on the piston for creating suction to draw the sample. Alright? But the piston does not touch the fluid. While for positive displacement pipettes class, the plastic tip contains an integrated piston. So, it touches the fluid just like a hypodermic syringe. So that's the difference between the two types of pipette, air displacement and positive displacement. While this one here class, as what you can see, these are diluter or dispensers type of pipettes. It can be either bottle top, so bottle top. It can also be motorized or digitalized. So these are an examples of diluter or dispenser type of pipettes. Just like all the other equipments and materials that we use in the laboratory, pipettes will also undergo quality assurance measures and quality control. So you have to make sure that the performance of the pipettes are verified. They're also checked, maintained, so there should be maintenance, and also calibration. It is recommended, class had, that pipettes be checked initially and subsequently 3 or 4 times per year, or as dictated by the laboratory's accrediting agency. There are already a lot of companies that offer calibration services. A quick daily check for many larger volume automatic pipetting devices involves, of course, volumetric flask. But you have to always make sure that your pipettes are within the standards. It must be accurate, it must be precise. So it must undergo all of these. Additional notes class, for volumetric to deliver pipettes, it should not be shaken or hit against the wall of the container during draining. If there's an interruption class, then that means the fluid being delivered to the receiving vessel is no longer accurate. Also, before aspiration of a certain or a desired solution, you have to first rinse the pipettes with distilled water, and then you rinse it again using the desired solution to be aspirated. This is to minimize cross-contaminations and carryover of the previous solution. And lastly, clean the pipettes with 5% sodium hypochlorite after usage. Next, let's discuss about the difference between glassware and plasticware. Glassware class these are laboratory equipments and materials that are made out of some type of glass. So you call them glasswares. As plastic material was refined and made available to manufacturers, plastic has been increasingly used to make laboratory utensils. And then that's the time they call it plasticwares. Regardless of design, most laboratory supplies must satisfy certain tolerances of accuracy and fall into two classes of precision tolerance, either Class A or Class B, as given by the American Society for Testing and Materials. Those that satisfy the Class A ASTM precision criteria are stamped with the letter A. So with the letter A on the glassware, and are preferred for laboratory applications. While for Class B glassware, they generally have twice the tolerance limits of Class A, even if they appear identical and are often found in student laboratories where durability is needed. Glasswares that are used in the clinical laboratory usually fall into one of the following categories. Kimax or Pyrex, so that's borosilicate glass, the very famous Kimax or Pyrex. There's also Corex or the aluminosilicate type of glass. There's also high silica glass. There's also Vicor. Vicor is the acid and alkali resistant type of glass. There's also low actinic or flint types of glass used for disposable material. But let's discuss each one of them one by one. A borosilicate glass, the Pyrex and Kimax, it is used for heating and sterilization purposes, and this one is most commonly used. It is characterized by a high degree of thermal resistance. It has low alkali content and is free from the magnesium, lime, zinc group of elements, heavy metals, arsenic, and antimony. It has a strain point of 515 degrees Celsius for Pyrex. The next would be Corex or aluminosilicate corning. It has a 6 times stronger type of glass than borosilicate glass. It is a special alumina silicate glass that has been strengthened chemically than thermally. Again, it is 6 times stronger than that of the borosilicate glass. Corex are ideal for higher temperature thermometers, graduated cylinders, and for centrifuge tubes. For Vicor, it is utilized for high thermal, drastic heat shock and extreme chemical treatment with acids, except hydrofluoric and dilute alkali. It can be heated up to 900 degrees Celsius. Kindly write that down. A Vicor type of glass could be heated up to 900 degrees Celsius. It's, again, recommended for high temperature, drastic heat shock, and extreme chemical treatment with acids and dilute alkalis. But except for, what is that again? Hydrofluoric acid. It's also ideal for ashing and ignition techniques. Another type of glassware is the high silica glass. It is radiation resistant, ideal for high precision and analytical work, and it can be used for optical reflectors and mirrors. Another glassware would be glass with high resistance to alkali. Another term used would be boron-free glassware or soft glass for this classification of glassware. It's boron-free glassware or soft glass. It's boron-free because it's free of boron, boron-free for strong alkali solution and digestion. It has a very high resistance to alkali, and its thermal resistance is less than compared to that of a borosilicate glass. Remember, it's boron-free glassware or soft glass. These are glass with high resistance to alkali. There's also low actinic glass. Low actinic glass are amber or red colored type of bottle glasses. They're used for handling heat labile substances. You call them low actinic glass. And lastly, the standard flint glass. The standard flint glass is made up of soda lime glass and a mixture of calcium, silicon, and sodium oxides. It has poor resistance to high temperature. With that saying so, it's easy to melt and used to make disposable glasswares. So it's used as a reagent bottle and a disposable glassware. Next are plasticware. Plasticware is beginning to replace glassware in the laboratory setting. The unique high resistance to corrosion and breakage, as well as varying flexibility, has made plasticware most appealing. It's relatively inexpensive. It also allows most items to be completely disposable after each use. The major types of resins frequently used in the clinical chemistry laboratory are polystyrene, polyethylene, polypropylene, Tygon, Teflon, polycarbonate resin, and polyvinyl chloride. Again, the individual manufacturer is the best source of information concerning the proper use and limitations of any plastic material. In most laboratories, glass or plastic that is in direct contact with biohazardous material is usually disposable. But if not, in the event that it is not disposable, then it must be decontaminated according to appropriate protocols set by the agencies of the laboratory. Should the need arise, however, cleaning of glass or plastic may require special techniques. This means immediately rinsing glass or plastic supplies after use, followed by washing with a powder or liquid detergent designed for cleaning laboratory supplies, and several distilled water rinses may be sufficient. Also, they recommend pre-soaking glassware in soapy water is highly recommended whenever immediate cleaning is impractical. Many laboratories use automatic dishwashers and dryers for cleaning. But do not forget, class, that detergents and temperature levels should be compatible with the material and the manufacturer's recommendations. That's to ensure that all detergent has been removed from the labware and You have to do multiple rinses with appropriate grade water is also recommended. Let's now proceed to the separation techniques. There are actually two separation techniques that we will be discussing. That's centrifugation and filtration. Centrifugation class is a process in which centrifugal force is used to separate solid matter from a liquid suspension. The centrifuge carries out this action, and it consists of a head or rotor, carriers or shields. They're attached to the vertical shaft of a motor or air compressor and enclosed in a metal covering. Right? The centrifuge always has a lid and an on or off switch. However, many models include a brake or a built-in tachometer, which indicates speed, and some centrifuges are refrigerated due to its very fast centrifugal force or centrifugation. It needs to be refrigerated. Remember that if there's too much friction, it can cause heat and spark, and that may be a cause for fire, so fire hazard. Centrifugal force depends on three different variables, that's mass, speed, and radius. The speed is expressed in revolutions per minute, that's correct, or RPM. And since centrifugal force generated is expressed in terms of relative centrifugal force or gravities. The speed of the centrifuge is related to the RCF by using this following equation: 1.118 times 10 to the power of -5 times radius times revolutions per minute raised to the power of 2. This 1.118 times 10 to the power of -5 class is a constant. It's determined from the angular velocity, while r here is the radius in centimeters. You measure it from the center of the centrifuge axis to the bottom of the test tube shield or bucket. This is what a centrifuge would look like. I suppose you already met one or you've seen one in the laboratory. And centrifuge classification is based on several criteria, including benchtop or floor model. So if it's floor model, then that's a big centrifuge. It's refrigeration, rotor head, either fixed. It's a hematocrit type, swinging bucket, or angled. While the centrifuge are generally used to separate serum or plasma from the blood cells as the blood samples are being processed. Centrifuge is also used to separate a supernatant from a precipitate during an analytic reaction. It's also used to separate two immiscible liquids, such as a lipid-laden sample, or you could also make use of centrifuge to expel air. In order to care for our centrifuge in the laboratory class, it includes daily cleaning of any spills or debris, such as blood or glass, and ensuring that the centrifuge is properly balanced and free from any excessive vibrations. Remember, balancing the centrifuge load is very critical. Another reminder, the centrifuge cover should remain closed until the centrifuge has come to a complete stop to avoid any aerosol contamination. It is recommended that the timer, or if it's present, and speed be periodically checked. There is also brushes inside the centrifuge. If there's present also, it should be periodically checked. The speed of a centrifuge is easily checked using a what again? You check the speed using a tachometer. Tachometer, Tachometer, or strobe light. So you use strobe light or tachometer in order to check the speed of a centrifuge. There are different types of centrifuge. The first one is the horizontal head or the swinging bucket centrifuge. This allows the tubes to attain horizontal position in the centrifuge when it is spinning and a vertical position when the head is not moving. Another type of centrifuge is the fixed angle or angle head centrifuges. They hold the tubes at a specific angle, usually 25 to 50 degrees to the vertical axis of rotation. So usually the names of the types of centrifuges comes from their positioning. There are also ultracentrifuges. These are commonly used to separate lipoproteins. The chamber is generally refrigerated to counter the heat produced through friction. They are called ultracentrifuges. Analytic chemicals class exists in varying grades of purity. So I have intended 2 slides for this. And actually, there's a total of 6 categories that I placed in this lecture discussion. And a committee of the American Chemical Society established the specifications for analytic reagent grade chemicals, and chemical manufacturers will either meet or exceed these requirements. Labels on reagents must also state the actual impurities for each chemical lot or list the maximum allowable impurities. The labels must also be clearly printed with the percentage of impurities present and either the initials AR if it's analytic reagent grade, or there should be an ACS. ACS stands for American Chemical Society, or the term for laboratory use, or ACS standard grade reference materials must be printed in the chemicals for reagent preparation. With all those types of labels that will indicate that those are suitable for use in most analytic laboratory procedures. Analytic reagent grade chemicals also are very important for qualitative and quantitative analysis, and this is used for trace element analysis and preparation of standard solutions. For ultra pure reagents class, ultra pure chemicals have been put through additional purification steps for use in specific procedures such as chromatography, atomic absorption, immunoassays. You add this in your notes, molecular diagnosis, standardization, or other techniques that require extremely pure chemicals. So this has been put through additional purification steps. These reagents may carry designations for HPLC pure, high performance, liquid chromatography, or chromatographic labels in their bottles. So that's for ultra pure reagents. Let's start first with USP/NNF. This stands for United States Pharmacopoeia and National Formulary. These grade chemicals here class are used to manufacture drugs. The limitations established for this group of chemicals are based only on the criterion of not being injurious to individuals. Chemicals in this group may be pure enough for use in most chemical procedures. However, it should not be recognized, or it should be recognized, by the way, that the purity standards are not based on the needs of the laboratory and therefore may or may not meet all assay requirements. So this is approved for human consumption. It's not injurious to individuals and may not be applicable for all laboratory analysis. While the reagent designations of CP or chemically pure or pure grade type of chemicals indicate that impurity limitations are not stated and that preparation of these chemicals is not uniform. So impurity is not stated, the preparation is also not uniform. For chemically pure or pure grade, it is not recommended that clinical laboratories use these chemicals for reagent preparation unless further purification or even the use of a reagent blank is included. While lastly, for technical or commercial grade reagents, they're used primarily in manufacturing and also should never be used in clinical laboratory setting. As we all know, class, water is the most frequently used reagent in the laboratory. Because tap water is unsuitable for laboratory applications, most procedures, including reagent and standard preparation, makes use of water that has been substantially purified. Water solely purified by distillation class is what we call distilled water. Kindly write that down. Water that is purified by distillation is called distilled water, while water purified by ion exchange produces deionized water. Again, you write that down. Water purified by ion exchange results in deionized water. This reverse osmosis class, which pumps water across a semi-permeable membrane, so it passes through a semi-permeable membrane, it produces reverse osmosis water. Write that down. When you make use of reverse osmosis, it passes through this semi-permeable membrane. It produces RO water. RO water. Okay? Water can also be purified by ultrafiltration. So it can also be purified through ultrafiltration, ultraviolet light sterilization, or ozone treatment. But actually, class, the laboratories require generally the call for the use of reagent grade water. According to the CLSI or the Clinical and Laboratory Standards Institute, this reagent grade water class is classified into 6 different categories based on the specifications needed for its use rather than the method of purification or preparation. So write down these 6 different categories that is set by the CLSI. Write it down, huh? I'll say it one by one. The first category is called the clinical laboratory reagent water. The clinical laboratory reagent water. Next is the special reagent water. Special reagent water. The third is instrument feed water. Instrument feed water. Fourth, water supplied by method manufacturer. So this is the water that is supplied from your manufacturer. Water supplied by method manufacturer. The fifth one is autoclave and wash water. Autoclave and wash water. And lastly, the sixth category is the commercially bottled purified water. There's already a convention that was conducted to categorize the water purity based on 3 types. So that's from type 1 to 3, with type 1 water having the most stringent requirements. Type 1 water. And generally, type 1 reagent water is suitable for routine laboratory use. These are the different definitions for type 1 reagent water. This is used for procedures that require maximum water purity for accuracy and precision. It's also used for ultra-microchemical analysis, measurements of nanogram or subnanogram concentrations, for microscopy, and preparation of standard solutions. Type 1 reagent water class is used for these different types of tests and instrumentation. Flame photometry, atomic absorption spectroscopy, blood gases and pH, enzyme studies, electrolyte testing, HPLC, trace metals, and even iron studies, and many more because this is used for most routine laboratory tests. Type 2 reagent water is for hematology, microbiology, immunology, and chemistry section. This reagent water, type 2, is also acceptable for any preparation of reagents and even for quality control materials. The type 3 reagent water is for urinalysis, parasitology, and histology. It can also be used for washing glassware in the clinical laboratory. Thank you so much for giving me your time today. I hope you've learned something new from me today. If you have any questions, clarifications, please message me in your Cello accounts so that I could address them. Once again, God bless us all.